Hello students, welcome to Saurav's classes. Today we are going to solve the problem which asks for the limit as x goes to minus infinity 3x square minus sine 5x by x square plus 2. So the way we are going to solve this problem is limit as x goes to minus infinity. We would like to divide the numerator and the denominator by x square. What it does is 3 minus sine 5x by x square by 1 plus 2 by x square. Now x goes to minus infinity implies x square goes to infinity and 1 by x square goes to 0. So if we look at this term sine 5x by x square, sine 5x oscillates as x goes to minus infinity, and so sine 5x is always less than equal to 1, greater than equal to minus 1. So sine 5x by x square is less than equal to 1 by x square, greater than equal to minus 1 by x square. Now by applying sandwich theorem, this goes to 0 and this goes to 0 implies this goes to 0. Below in the denominator, of course, 2 by x square also goes to 0. So we are left with 3 and 1. So the limit is 3. Now let us move on to the next problem. We want to find the smallest integer that produces remainder of 2, 4, 6 and 1 when divided by 3, 5, 7 and 11 respectively. So 3 divides k minus 2, 5 divides k minus 4, 7 divides k minus 6, 11 divides k minus 1. Now 3 divides k minus 2 plus 3, as 3 divides k minus 2 and 3 divides 3, which implies 3 divides k plus 1. Similarly 5 divides k minus 4 plus 5, which implies 5 divides k plus 1. Again 7 divides k minus 6 plus 7, which implies 7 divides k plus 1. Now from these three we get 3 into 5 into 7, since these are prime numbers, divides k plus 1, which says 105 divides k plus 1. So k plus 1 can be 105, 210, 315, 420, 525, etc. Let us check the first few by hand. The divisibility by 11. So what is k minus 1? So k minus 1 is equal to 103, 208, 313, 418, 523, etc. Now checking its divisibility by 11, 103 is not divisible by 11, so we can cross it out. 208 is not divisible by 11, again we cross it out. 313 is not divisible by 11, so we cross it out again. But 418 is divisible by 11. So 418 is the required number. K K is equal to 418 plus 1 is equal to 419. So C. I will just go through the problem once more. We were given that 3, 5, 7 and 11 has the following reminders. Now 3 divides k plus 1, 5 divides k plus 1 and 7 divides k plus 1 together gives us 105 divides k plus 1. So k plus 1 can be 105, 210, 315, etc. etc. We have to take at most a set of 12 numbers to find same reminders while dividing by 11. So we just check by hand and see that k minus 1, the lowest k minus 1 for which it is divisible by 11 is 418. So k has to be 419. Option C is the correct answer. Now let us move on to the next problem. This problem will be solved by using a combinatorial argument. It asks for the probability that among the 12 months there are 6 containing 2 birthdays each and 6 containing 3 each in a group of 30 people. So my argument is as follows. Let us say the people be arranged A1 to A30 in the increasing order of their birthdays. So now at first what we need to do is to find out the total number of choices. The total number of choices is for each of the 30 people there are 12 choices for their birthdays to fall in the 12 months. So we have 12 into 12 up to 30 times, which gives us 12 to the power 30 total choices. Now number of required choices. By number of required choices I mean the number of ways in which we can arrange the people so that there are 6 containing 2 birthdays and 6 containing 3 each. The first thing to do is choose 6 months out of 12. After choosing 6 months out of 12, what we do is we create blocks like this from January all the way till December. Suppose we have chosen 6 months in which the number of birthdays are 3. Suppose January is a month in which the number of birthdays are 3. We create 3 blocks. Suppose February has 2, we create 2 blocks. Suppose April has 2, we create 2 blocks. And suppose December has 3, we create 3 blocks. Note that since we have chosen exactly 6 months, we in different choices we get different combination of 6 months having 3 birthdays. Once we have created these blocks, we can just arrange the people in the same order. So what we have is 12 choose 6 times 30 factorial. However, in a particular month, suppose in January we have A1, A2, A3. Now this choice will be regarded the same as A2, A1, A3, as we do not really care about the permutation of the various choices. We just care about the number of people that we can fit into 1 month. So we have 3 factorial to the 6, 2 factorial to the 6. This divided by 12 to the power 30, which is option A. I'll go through the problem once more. Given 30 people, we want to find the probability that among the 12 months there are 6 containing 2 birthdays and 6 containing 3 each. Total number of choices for each person is 12 because there are 12 months. So 12 to the power 30 is the total number of ways in which their birthdays can occur. Now what we do is we choose exactly 6 months. Let us assume we choose the 6 months in which we want to have 3 birthdays. What we do is exactly those 6 months we create 3 blocks, and the other 6 months we create 2 blocks. Now we arrange the 30 people in these blocks, which gives us 30 factorial. However, in each month we have to consider that there are permutations. Suppose A1, A2, A3 is in January, then A1, A2, A3 is the same as A2, A1, A3 or A3, A1, A2, as we do not care about the permutation of the birthdays coming in 1 month. We just care about the number of birthdays that come in 1 month. So there are 6 months having 3 birthdays, so we have to divide by 3 factorial by 6, and there are 6 months having 2 birthdays, we have to divide again by 2 factorial by 6. So the correct answer that we get in the end is 30 factorial by 3 factorial to the power 6, 2 factorial to the power 6 times 12c6 by 12 to the power 30, which is the option A. Thank you.